we're going to take a Java class and we're going to convert it into an Objective-C class. That's what we're going to do here right now. We have 3 windows on this screen. We have on the left here, we have our Java class. It's called, the class is called interest. And then on the right, we're going to have 2 other screens to handle our source file in Objective-C, or our class in Objective-C. There's a reason why I have 2 windows. If you go back to C, in C we had 2 files. We had a header file and we had a code file. And what we're going to do here is the exact same thing. We're going to convert it into a header file and a code file here as well. So we have here a class called interest, and we call it interest.java. And so what we're going to do is we're going to start off with the header file, and maybe I'll just make a little comment and say this is our header file. And because the object is going to be called interest, we want to call this file interest.h. And consequently, over here, we want to call this object interest.m. So we want to call this file interest.m. And this will be our source file, just like a .c file in C. Now, the question comes to mind is, how do we break up this Java class so it looks like a class in Objective-C? Like, what goes where? So the first thing we want to start off with is looking at what's in our Java class, and we see we have a few private variables, we have a bunch of methods and some constructors. So what would go into the header file to start off with is our variables. We'll push our variables over to the class, to the header files class, or the class's header file. And the way we do it is, the first step is to include in a very important header file, which is the Foundation Frameworks header file. So we're going to say import foundation/foundation.h. And so this is saying go in and get the header file for the Foundation Framework so that we can actually start using stuff within the Foundation Framework. Now our next step is to start defining the object, but from the header file's perspective. So we're going to start defining the object in terms of what's in it, what's the structure of the header file, of the object. So we're going to say at interface, and this object is called interest. Now, this in Java would have been sufficient, just to say public class and interest, right? And in Java, we learned that by default, all objects are a child class of the highestmost object, which is object. And so the same could be applied here in Objective-C. All objects are the child object of NSObject. But the difference is that unlike in Java, where it's implied, and we don't ever have to actually type anything out to signify that, we actually have to do that here in Objective-C. We actually have to say that it extends, so we use a colon to say extends NSObject. So we always have to say that this extends from the parent class, which in this case is NSObject. So it's a bit of a different approach to it, where we are so accustomed to having having Java imply that we are extending object. So we are taking that for granted, but here in Objective-C, we actually have to physically say it. And we'll find that there's a few things also in Objective-C we actually have to just physically say it, whereas it was implied in Java. And we'll see those as we get through this example. So our first step is to define the object. And what we do is we start with the variables at hand. And if we look at the variables we have private double principal, private double interest, and private double years. But they also have a couple more variables, double int cost and double total loan, meaning total interest paid over the loan and total loan cost, including principal and interest. And so what we want to do is define these variables. So we're going to open a curly bracket below this and define these variables. So we'll say double principal, double interest, and double years, as well as double int cost and double total cost. Okay, and so we have now defined the variables that belong, the class variables that belong in our class. But the next step now is to define any methods that belong in this class. And that also includes getters and setters. So what we're going to do is we're going to start off by defining the getters and setters for the variables, and then pause this header file, move into the M file, build the M file, and then come back and finish off the header file with all of the methods that went inside the M file. It's a faster process. It makes life easier in the end. So the way we define the getters and setters will be a lot easier here than it was in Java. In Java, it was very tedious. We would define get and set, get and set, get and set, get and set for every variable we have, which is painful and annoying. But here, we simplify things down to 2 lines of code. And what we're going to do on the header file side is we're going to define the function prototypes for get and set. But that has been simplified down to an easier line of code to remember. And it's a bit tricky at first to remember it, but over time it'll make more sense. So we use this property called @property, and we'll just say principal. Double principal. And then we'll do the same for interest in years. So we'll say @property double interest and @property double years. And this is now defining the function prototypes for the gets and sets for the variables. So we haven't defined the gets and sets here. We define the function prototypes here. So what happens is the compiler, when it's compiling this header file, will take this line of code and replace it with get and set, get and set, get and set for us. We won't see it, but the compiler will do it behind the scenes and inside our binary. So this reduces the headache of having to write get and set, get and set. It's already cut our coding time in half because we're just using these small little lines of code. Now, we can go ahead and override things. We actually physically write our own get and set ourselves. It's allowed. We can do it, right? It's only in instances where we really need it that we may want to do that. And also, anything that has a pointer in front of it, there's a slight modification to it, and we'll see that as we do other examples and as we get into writing an app. We'll see that used more often there, and I'll explain in greater detail when we get to that point. But for now, we'll just do the other two because we haven't done int cost and total cost. And then we will pause this header file and move on to the M file. So we'll say @property double int cost, @property double total cost. Okay, so we got all 5 variables there. And now we'll end off the file. So anytime we want to end off the file, we just say @end. And then that ends off the header file. But we're not really done with it. We're just going to pause it for now and move over to the M file. And so what we do in the M file is, and we're going to assume that it's called interest.m to match the name of the class. What we're going to do here is we're going to start by importing interest.h. And you'll notice that my double quotes are different for interest.m than what I use for interest.h. The main difference between the two is that interest.h is a file we created. So any file we create that we're importing, we use double quotes. But foundation.h is a file that belongs to the system, or essentially to the foundation framework. So in cases like that, we're using angle brackets. So think of it as any system files have angle brackets, any files we created or local files have double quotes. That's the main difference between the two. But this rule also applied in C as well. So this is not new. This is just carryover from C. So in the H file, we said at interface and then interest to define our object for the header file, or at least the structure for the header for the object. Now, for the source file, we're going to say we are going to implement this object here. And we use the at implementation interest. This is saying now that we are going to define the object here, but we're going to define the source code, the actual method definitions and whatnot for this object. Our first step here is to finish off defining the getters and setters. So in the header file, we used property to define the function prototypes for the getters and setters. And here in the M file, we're going to use at synthesize. And this will define the actual getters and setters. So we'll say at synthesize principal, interest, years, int cost, and total cost. And so what happens now is at compile time, when you hit compile, the compiler goes and he sees this line of code and says, okay, these are my getters and setters. So I'm going to replace this line of code with get and set, get and set, get and set, get and set behind the scenes in the binary. So we never see it, but it's done for us. It saves us that time. It saves us that headache of having to write it out ourselves. So you've already seen that we've cut our coding time down dramatically just by not having to write get and set, get and set, get and set. But like I said earlier, we can override any particular get sets we want with code that we want to have. So for example, suppose I had a variable and it was tied into the accelerometer. Like let's say I had a ball on a screen and I was tilting the phone to get that ball to move around the screen. And maybe I wanted the XY location of that variable and I want to save that into a variable like X and Y. I could overwrite the get and the set for the X and Y so that every time the phone tilted, then it would retrieve the X and Y and save it in my XY location directly from the accelerometer. So that might be an example of overriding a get and a set. And we would just simply override it by just writing out the get and set method as we need to. Even if we did synthesize, we can still override it. So we have that at our disposal to further customize it as we need to do. So if we're not happy with it. All right, so we define the object, the implementation interest. We are synthesizing our variables. You'll hear me say synthesize quite often. Synthesizing our variables, that's what I mean by it. So we're synthesizing our variables. And now we're going to go ahead and start creating our constructors. So what we want to do now is we want to look at the two constructors we have. So we have public interest, where we have principal 0, interest is 0, years is 0, and then we call a method called calcInterest, which we have further down. We have a second constructor where we are setting interest, the principal in interest and years, and then calling calcInterest right below it as well. So there's two constructors here that we have. We're going to implement those two constructors in our M file. And what I'm going to do is I'm going to start off with the constructor that has P, I, and Y passed in, and then we will define the default constructor afterwards. And there's a reason for it that you'll see in a moment. So our first step is to define our constructor. So our constructors always have a return type of ID, and they always start with the word init. So a default constructor would typically have the word init, might not have any arguments at all, like so. But you can also expand upon the word init to be more descriptive, especially when you have arguments that you're passing into your constructor. So I might say ID return type, init with data, for example. There's a ton of init functions in Objective-C, such as init with frame, init with size, init with data, init with person, and init with food, or whatever, and so on, right? But there's all kinds of init constructors out there, and being descriptive like this helps out quite a bit when the coder is trying to write out what they need. Now the nice thing about Xcode is that they autocomplete, so it'll show you the list of options available at your disposal for init. so that you can make it easier in choosing what you want to write. So in this case, I'm going to pass in 3 arguments. All 3 are doubles, and they are principal, interest, and years. So I'm going to start off with double P for principal. And then my second argument, I'll use a label like the interest, and it'll be a type double. It'll be a type double, and we'll call it I. And then my third one will be the years. It'll also be a double. We'll call it Y. All right, so we have init with data. We are passing in P, I, and Y. So our first argument has no label, it's just P, type double. Second argument has the interest as its label, and it'll be called P, or sorry, I. And the third argument is called Y, and its label will be called the years. Okay. Now we can go ahead and define the constructor. And so there's a consistent process with defining constructors. And so the way we define constructors here, you'll be doing it over and over and over again. But our first step in defining a constructor is to call the constructor from the parent class. Our parent class here is NSObject. So we want to call the constructor from NSObject, or in essence, the super constructor. So we'll say self. And whenever we say self, we're referring to the word this. So we use this in Java. We're using self in Objective-C. The difference is that we are using self everywhere in Objective-C. In Java, we had only a couple of instances where we actually used the word this, and we really needed to use this in that case. But in Objective-C, everything is self. Like we use it, you're going to see us use it heavily here. So I'm saying self, I'm going to say super, init. So this is calling the constructor from the parent object, or NSObject's constructor, making sure that it goes through its motions of allocating memory and doing what it needs to do to create the object before we proceed further in our own customized constructor. Now, when it calls the constructors init, it should return something valid, meaning the self should not be nil. We want to test for that. So we might say if self does not equal nil. In instances where it does end up being nil, it could be a case of, you've overloaded your phone with like 50 apps. They're all running at the same time. Maybe you're running Angry Birds while you're trying to play Cut the Rope, while you're trying to play Crossy Road, and you are just trying to play them all at the same time and win some record, and you're just killing your phone, and your phone's crying for help, and there's blood coming out of it and sweat coming out of it, and it's really, it's just begging for mercy. In those cases where you're basically running out of memory. So in essence, you may not have anything returned. You may just have nil. Right? You may not have any memory allocated for your object, so it won't be able to do anything. So in this case, there's no point. This will just exit badly. Right? And at that point, you'll have to close off apps and try and free up some memory to get your app up and running again. But in this case, assuming that it did, and 99% of the time this will work and this if statement will execute, we can go ahead and set our values. So we might say self set principal with P, self set interest with I, and self set years with Y. And we'll do one more step because it's written over here, calc interest, but we'll save it for later. So I'll just put a comment here, just saying calculate interest, because we still have to create the method to calculate interest. And the last step in our constructor is to return self. The reason why is because if we look at this method declaration, its return type is ID. All constructors return ID. It returns an anonymous object. And it does that because we don't know the type we want to return. We never know the type until runtime. So we have to use this anonymous object as a placeholder, kind of similar to void pointer in C. So in C, we might have used a void pointer to say, hey, we got some argument we're passing in or we're passing out, and we don't know what it is until we actually call up that function at that point, right? So it's a similar idea here with ID. We won't know until runtime what we're passing in or passing out. So in this case, we're returning self, which is our own object, right? So that's why we return self. Now at this point, this constructor is complete, so we can actually go to the default constructor and finish that one off. So with init, I can save myself a lot of headache by not rewriting that code below, up here, by saying return self init with data and pass in 0.0, the interest as 0.0, and the years as 0.0. And that's it. But do you see what I did here? I did something here that we can't do in Java. Call a constructor from another constructor. It's unheard of in Java. We can't do that. But here, we can treat the other constructor like methods and actually call those methods within each other. Now, suffice to say, you can't go ahead, and you actually shouldn't go ahead and actually call a constructor from another method, because that just poses a lot of problems, right? That just poses a lot of problems. But realistically, you can call a constructor from another constructor, which saves you a lot of coding time. So your best bet is to code the biggest constructor you have, the one that has the most processing involved in it, and then call the little constructors from using the bigger constructors. That's the best approach you can take. So it saves you a lot of coding. So now that we have the constructors in place, there's only one method left, and that is calc interest. So I'll put calc interest here at the bottom. Right? So this will just be void calc interest. And we'll set the initial interest cost to 0. So we'll say self and set int cost to 0.0. And then we'll just loop through and calculate our interest and calculate our total cost. So in the Java side, we have the method already defined. So we're going from 0 to years minus 1, essentially adding up the principal times the cost, the interest, and then adding it all up, and then in the end doing the total cost being principal plus interest costs. So very simple interest, nothing compounded quarterly or anything like that. We'll just do the same thing here. So we'll say for int I equals 0, I is less than years, I plus plus, and we'll just say self.int cost is equal or plus equals, and then self.principal times. Now in Java we use math.pow, but in C we can just use pow, right? So we can just say pow for self.interest and I. And then add up the total cost afterwards. So self.total cost equals self.principal plus self.int cost. And that's it for the method. So that method's complete. That's to calculate our interest. The only thing left is to end off this file by saying @end. At this point, the M file is complete. So we just simply define an interest method to calculate the interest and update our int cost and our total cost. So we have our total interest, we have our total loan with the principal and the interest together. The only thing left would be to create a method to just print everything back out. We could use nslog. We could use it here to print out do an nslog for int cost and total cost. In fact, let's go ahead and do that. We didn't do that in the Java, but we'll do it here just to illustrate how nslog might be used. So if I want to print this back to the screen and not print it back to the app because we need like labels and whatnot to do that, we might say nslog, don't forget the @ symbol, and say interest cost is and %f. And then we'll just pass in self int cost. And notice that I'm mixing the dot syntax with the bracketed syntax. I'm doing that on purpose. You should try and be consistent in what you do, but I'm being inconsistent here just to show you both ways, and both ways will work. So it's up to you to choose which one you want to use. And I'll just do an nslog and say total cost is and %f for self total cost. And then that completes that method. There's only one step left in this object, and then we're done. Is to take all of our methods and put them in our header file. Now, here's where that discussion of public versus private comes into play. So I said that there is public and private, but we're going to use the header file to control what gets accessed outside. So if we look at the current header file, we have all these variables. All these variables are considered now public in a way because they're now accessible to the outside world. But they're accessible through getters and setters, so they are still private in a way. What we want to do now is look at the methods. There's no methods here other than the getters and setters for the variables. And we want to make our methods accessible to the outside world. So anybody that imports interest.h will have access to the methods. Right now, if somebody imports interest.h, they have no access to the methods. They have no access to calc interest because it's not accessible. It's not in the header file. So it doesn't know what calc interest is. So if I want calc interest accessible, then what I like to do is I like to just copy and paste it just above the end and put a semicolon at the end. So it saves me that headache of coding it over again or coding it from the beginning. And if I go to init with data, copy and paste into the header file, throw a semicolon at the end of it, and then my third constructor, init, or my second constructor, init. Now these methods are available. The thing about the constructor is if I don't put the constructors in, then it'll use a default constructor that has nothing to do with what these constructors are defined as. And so what we want to do is include our constructors in the header file. Now there's one step I missed in the constructor, and that was calculate interest. So if I look back at init with data here, I want to calculate interest, so I'll just say self calc interest. Now the object is complete. And so we've basically created an object. We've used the Java object of calculating interest. We had some variables, principal, interest, and years. We had total cost of loan and whatnot that we calculated. We had a couple of simple constructors, and we had a calc interest method. We printed that back out to the user. But essentially, here's an example of how we created an object called interest, and we converted it from Java to Objective-C.